All right, so let's talk about this section in chapter 6. The last one in chapter 6, 6.3, last one we're going to cover is about Kramer's rule. So Kramer, this is our Swiss mathematician, Gabriel Kramer. He discovered this formula and he had named after him, so very famous mathematician here, on how to use the coefficient matrix and determinants to solve linear equations. So we'll kind of go through this, show you how to do it, and then there's 2x2 and 3x3 ones that you can work on. All right, so again, what is coefficient matrix? So if we have this linear system here, what the coefficient matrix is remember, it's just the coefficients and not the solutions. So in this case here, for this example, we have the 1 in front of the x and the -5 in front of the y, and then the second equation would be -7 and 2. That would be our coefficient matrix. We're not including the 9 and the -30 here because those are not coefficients. Those are solutions on the other side, or constants. And so we're just looking at coefficient matrix. So we got to know what that is. And then we're going to use Kramer's rule down here. So Kramer's rule says that if you've got these equations, that's what all this math says, then if you've got your coefficient matrix, which we just talked about, in this case they said A, B, C, D, then if we have a determinant that's equal to 0, now the one thing I want to point out, or that's not equal to 0, if the determinant is not equal to 0, remember, right, determinants like with those bars, it looks like an absolute value, but it's not, so it's another symbol for determinant. So if the determinant is not equal to 0, then the system has a unique solution given by these formulas, okay, which is right here. You're going to take the determinant of that, EF and BD, and over the determinant of A, and then for Y, the Y coordinate, you would take a little bit different, AC, and then EF over the determinant of A, okay? So where did we get those from? Okay, so we know that our coefficient matrix is how we got the A part. That's right here. We know that part's going to go at the bottom here where we divide. But where do the other numbers come from? So basically, you're taking the first column, and you're taking these E and F, these constants on the right side of the equal sign, and you're going to just replace them where the X coordinates are, right? So in this case, we kind of replace them into the left side, right? And then we keep BD the same. But for Y, we're going to take that EF and we're going to replace it where the Y variables would be. Okay, so you just kind of, and AC stays the same. You just kind of replace those numbers in E and F for the coefficients of X when you're trying to get the X value and Y when you're trying to get the Y value. Okay, and then you just do the determinants, which we know how to do, a quick diagonal multiplication and subtraction, and we're good. Okay, just one more thing to point out on that is that if we get into a situation where we have the determinant of the matrix equals 0, then the system has either no solution or infinite number of solutions. Okay, it does not have a unique solution of a point x comma y. It would have to be either no solution or infinite number of solutions, and you could find that out based on the information that you got. All right, so let's use Kramer's rule to solve here with a 2x2. Okay, so first thing we're going to look at is I'm going to label A as my coefficient matrix. Okay, so A is just going to be simply the coefficients of this example right here. So it'd be 1, -5, -7, and 2 is my coefficient matrix. So the first thing I have to do is I have to find the determinant of A, right? So to do that, again, I'm going to multiply diagonally. So 1 times 2, right, is 2 minus -7 times -5 is a positive 35. So then I have my determinant is -33. Okay? So I need that because that goes in the denominator of this formula here and here for x and y. Okay, so now I'm trying to find x. So I'm just going to switch colors here just so we can see that. So when I'm trying to find x, remember my matrix that I'm going to use, I'm trying to find the determinant, is I'm actually going to substitute these numbers in, right? And I'm going to sub them into the first column because that's where my x's are. So it's going to be 9, negative 30 here. And then the other column is going to stay the exact same as it did in A, negative 5 and 2. And then I have to find over the determinant of A, which we already did, is negative 33. Okay? So now I'm looking at the determinant of the numerator here on top is going to be, well, 2 times 9 is 18. Okay? And then minus, and I've got a negative 30 times a negative 5, which is a positive 150. And all that's going to be over 33. So when I can combine those, I end up getting, what's it, negative 132 over negative 33. It kind of works out nicely for us that x is going to be equal to 4 here. Okay, so that's part of it. Let's do y. So I'm going to change colors again just so we can see that. So for y, now remember I'm going to take this 9 and negative 30 and I'm plugging it in the second column because that's where our y's are. So the first column of that matrix is going to stay the same. For here, it's going to be 1 and negative 7, but I'm going to replace that second column with my 9 and negative 30. Then I got to find the determinant of that, and of course put it over negative 33. So a little bit of work here, but it's easy calculation work. So doing this one, again, 1 times negative 30 gives me negative 30 minus negative 7 times 63. Negative 7 times 9 is negative 63. But remember, I'm going to choom that to add that. So that gives me 33, positive 33, which over a negative 33 from my determinant of A becomes negative 1. So I know that y is equal to negative 1. And then we can finish by putting our answers in a ordered pair. 4, comma, negative 1 would be my answer here for that solution. Okay, let's do another one. Okay, so for this one, again, looking at my A, that's the coefficient matrix. So I'm going to go 2, 6, 5, and 1. And that's going to give us the determinant of A then would be 2 minus 30, which would equal negative 28. So I've got that. Now I'm going to try to find my x's and y's. Okay. So again, for my x, I'm basically replacing this 2 and the 5 with this 38 and negative 3, right? Because that would help us out in doing that. So now the first column is actually going to be 38 and negative 3 instead of 2, 5. Second column stays the same, 6 and 1. And then, of course, it's going to be over that negative 28 because that's the determinant of A. So we have to do that one first. Okay? So finding the determinant here of this one, I should have just left it a straight line. 38 minus plus 18, right? Because it's going to be minus and minus 18. So plus 18 gives us 56 over negative 28, which equals negative 2. Okay? For y, again, now I'm replacing the 6 and the 1 with the 38 and the negative 3. And the first column is going to stay the same. So I'm going to have 2 and 5 on the left column. On the right column is now going to be 38 and negative 3. All over the negative 28 because we had to do that determinant of the coefficient matrix. So just a lot of finding determinants and then solving with subtraction or division. So here I'm going to have the determinant here would be negative 6 when I cross multiply, and then minus 190, 38 times 5, which is going to be equal to negative 196 when I combine those over negative 28, which then equals 7 when you do that math. So my final answer here would be, in an ordered pair, negative 2, comma 7. Okay? All right, let's save example 3 for in class just so we can check through this again and then speed through time. It'll be very similar. You can do it on your own if you want, just to get a little extra practice, but we'll do that one in class as well. Let's shift to the other side. So now we're talking about 3 by 3 variables, 3 variables and a 3 by 3 matrix. Okay, so a lot of letters here, a lot of stuff to look at, but it's all basically kind of the same different pattern, right? So my coefficient matrix, we said it's just going to be these coefficients, right? The A, D, G all go right here. B, E, and H all go right here. C, F, and I go right here. And I'd have to find that determinant. Okay. Well, remember, we have plenty of ways now to find that determinant of a 3 by 3 matrix. Okay. You've got a couple different methods in which you can do that. So we'll have to do that. And that, of course, is going to go down here in the denominator of these. We have to do 3 different ones. These take a little longer because now you have a third variable, X, Y, and Z. Now, how do you replace it, right? Notice that, again, we didn't do anything with these numbers in the coefficient matrix. Okay, J, K, and L are not there. Same thing, when I'm trying to find X, I'm going to replace J, K, L with the first column. And then the rest of them stay the same, right? They're going to stay B, E, and H, and C, F, and I, just like they did in the coefficient matrix. Then when I'm trying to find the Y coordinate, I'm going to replace J, K, L with the middle column, because that's where my Y values would be. And the other ones stay the same, right? ADG would be on the left, CFI on the right. And the last one, of course, if I'm trying to find Z, that means I would replace JKL with the right column because that's where my Z variables are. And then the other two would stay the same. ADG and BEH would stay the same as they did in this coefficient matrix up here. Okay, so let's do an example and see how it goes. It takes a little bit of time to do these ones because you're going to have to find the determinant of all these other ones. So let's first start. I'm going to do some work in here in example 4 with finding the determinant here of A, our coefficient matrix. So I'm just taking these coefficients, right? -1, 2, and 3. And then 7, 1, and -5. And then these coefficients, 2, 9, and 2. Sorry, -2, 9, and 2. And just make sure you have the right signs and everything there. Now, again, this takes a little bit of time, but you'll have to find the determinant of this coefficient matrix because that goes in the denominator. I'll save the time and tell you that it's 140. Okay, now you can use multiple ways. You now know that there's a way with a graphing calculator. You can also use the 2 other ways that we talked about before, the diagonal method we just showed you, or you can use the other method, the first method we use, which they call expansion by minors. That's where you take, the top row and multiply it by the determinant of the other 4 that aren't in there, or that aren't in that row, right? The very first way, I guess is what you call it. And they call that expansion by minors. So you have that method, you have the diagonal method, and you have the graphing calculator method to find the determinant of this if you want to. That'll save you some time. But I'm doing it right here. The determinant of A is 140. Okay, so now we got a lot of work to do with our X's and our Y's. So let's start going with X first. Okay, so X. Remember, my X coordinates, these are the ones I'm going to replace. Replace that whole thing, this whole column, with these numbers right here. So my new one is -14, 43, and 2 in the left column. Now the other 2 columns are going to stay the same. 7, 1, -5, and -2, 9, and 2. Okay, again, saving time, I'm going to just give you what the determinant is here. But you have to, this is where it takes time because you'll have to do that math. The determinant of that is -700. I'm just kind of saving time here over 140. And remember, we know there's methods on how to do that. And that's going to equal a -5. Okay? For Y. Now, again, in Y, I'm taking these values here and replacing them with this middle column. The left and the right columns are going to stay the same. So the left column is going to be negative 1, 2, 3. The middle column is what I'm changing, negative 14, 43, and 2. And then the right column is going to stay the same as negative 2, 9, 2. So just placing them in the right place and then doing the determinant. So if you find out here, any method you'd like to find the determinant of this 3 by 3 matrix, it comes out to negative 140 over 140 is going to be negative 1. And then Z, finally. So it looks simple. I'm sorry, I forgot to put, we got to put it over 140 here. You got to put this one over 140. That's where these are coming from as well, because 140 was the determinant of A. Okay, for Z, same idea. Again, in blue this time, these three numbers are going to replace these three numbers in the coefficient matrix. The first two columns are going to stay the same. So negative 1, 2, 3, 7, 1, negative 5. And now I replace the third column with negative 14, 43, and 2. All of that over 140 because that was the determinant of the original coefficient matrix. And away we go. Any method you'd like for that 3 by 3 determinant, you're going to get 840 over the 140, which comes out to 6. So now I can get my final answer in a ordered pair. Not an ordered pair, it'd be an ordered triple, negative 5, negative 1, positive 6 would be my final answer here, XYZ. Okay. Hey, let's do one more while we're at it, just to kind of get the idea of what it would look like. So again, looking at my coefficient matrix first, I'm just going to use the coefficients here of 3, 1, 5. The middle column, negative 1, 2, negative 6. And the third column, 1, negative 7, negative 2. So if I find the determinant of A, again, so you have to do this 4 different times. You have to find these determinants of 3 by 3 matrices. So use your strategy that you prefer. In this case, it ends up being the negative 121. If you do the math, again, I'm going faster on that, but expecting you to know how to find that determinant. So now when we go for it, X is going to be equal to, again, what am I going to do? I'm going to replace this column with the numbers to the right of the equal sign. So negative 23, 63, and negative 14. And then the next two columns stay the same. Find the determinant of that, put it over negative 121. And again, I'm saving time of showing you work on that. 484 is your determinant here over negative 121. That divides evenly, negative 4. Okay, Y value. Just to show you again, what am I doing? I'm going to take these numbers to the right of the equal sign and replace them the middle column. The other columns stay the same as the coefficient matrix. So 3, 1, 5. Now I replace the middle column in the right column, 1, negative 7, negative 2. And all of that over my negative 121. Don't forget about that. This determinant is going to be negative 242 over negative 121, which comes out to a positive 2. Finally, let's look at Z. Again, what am I doing? Taking these numbers to the right, replacing them in the far right column. The left and right are going to stay the same. So I'm going to have 3, 1, 5, negative 1, 2, negative 6, negative 23, 63, and negative 14, all over negative 121. Find the determinant. Again, that's going to take the most time. I've got 1089 over negative 121, which then equals negative 9. So I've got my solution now. It's going to be in an ordered triple, -4 to -9. Okay, so that is Cramer's rule, both with 2x2 and 3x3 matrices. Oh, that Cramer, how crazy he is that he came up with this. What a discovery. Kind of helps us to solve these solutions even easier. So we'll work on this. Bring any questions you have. Yeah, we'll see you next time when I see you.